Hello students, my name is Shashank Shekhar. So today we'll start the chapter Electrochemistry. So previously we have ended the chapter that was solution. Today I will give you a brief introduction of this chapter as it is the first class of this chapter, first lecture of this chapter. So let's start this chapter Electrochemistry. So if you look at the syllabus here, so today I will be basically covering this part in which I will be introducing you what is redox reaction. Okay, so you must be aware about this term redox reaction as it will be seen throughout this chapter, right? So I will just introduce you with this topic only today. The rest of this EMF of a cell and rest of the topics will be covered tomorrow. So if you look at this syllabus topic related today's that are to be covered, so the first one will be oxidation number. Then I will say you what is redox reaction and how this redox reaction is used in electrochemical cells. What are the cases of electrochemical cell? And how does this cases give rise to two types of cell, which are electrolytic cell and galvanic cell. Later on, I will just introduce to some of the terminologies and the ways in which you can remember these terminologies. So it is just, you can say it is a mnemonic device that can be used to remember this terminologies because students do get confused in this terminologies, right? So let us start this chapter. So first it is oxidation number. So what is oxidation number? It is a hypothetical number assigned to an atom in a compound, which is the charge if the compound was composed of ions, right? So I am saying that that it is not an actual charge or actual number. It is a hypothetical number or a hypothetical charge that is assigned to the atom in a compound if the compound was composed of ion. I said if the compound, but since all compounds are not composed of ion, some are having covalent bond, some are having coordinate bond, and different type of bonds are there in chemistry. So I'm considering that right now I'm considering that they are all composed of ions. Then in that case, what will be the charge? So this thing is done by using oxidation number. What is this use of assigning oxidation number? We can see that which atom is losing electron, kind of, because you cannot say that the atom is completely accomplishing that electron. It is kind of partially more attracted towards that atom which is having the negative charge and partially less attracted towards that atom which is having positive charge, right? But that charge distribution can also be verified with the help of this oxidation number. So let us start the oxidation number. The first and the foremost rule I would like to you to remember always is that if you are seeing a homoatomic molecule which is having a neutral charge, okay, so if you are seeing a homoatomic molecule which is having a neutral charge, then the oxidation number of each atom in that compound or molecule will be 0. So this thing is very important. So children children had always made mistake in this point that they assign oxidation number to this homoatomic molecule which are neutral. So do not do that. Oh, so what is this point? This point says that suppose we have this O3, right? So you will say what will be the oxidation number of this? Means what is the oxidation number of oxygen in this? So if I write ozone, it looks like this. Suppose I assign number to each of this. It is oxygen 1, it is oxygen 2, and it is oxygen 3. Then I will say that oxidation number of oxygen 1 is equals to oxidation number of oxygen 2 is equals to oxidation number of oxygen 3. Do not get confused. It is not the number of atom, it is the numbering I am doing, that it is 3, it is 2, and it is 1. Let me write it with a different pen so that you do not get confused. So it is the first oxygen, it is the second oxygen, and it is the third oxygen. So each of these have a same oxidation number which will be equals to 0. Okay, which will be equals to 0, right? So here some more examples are given related to this point, which are oxygen, ozone, phosphorus, and acid. So all of this in their elemental form, you can say, have a oxidation number 0. We can have more examples like this. So if I say that we have an atom that is, a molecule that is fluorine. So what will the charge on fluorine? So what, it is a kind of homoatomic. So what do you mean by homoatomic? Means both the participating atom or all the participating atom in that compound are same and they are neutral. So this point should be kept in mind, that that overall charge on the compound should be neutral. Then and then only each atom of that compound, homoatomic compound, will have a oxidation number 0. Here also the fluorine will have an oxidation number of 0. So if I just write it above, so it is 0. Similarly, you can have chlorine 2, you can have iodine 2. Likewise, you can have this, say, Br2, N2. So in all of this, the nitrogen will have a charge of oxidation number of, more appropriately, oxidation number of 0. So in a nutshell, I want to say that all atoms of a homoatomic molecule which is having an overall charge 0 will have an oxidation number 0. So this was our first point regarding how we can calculate oxidation number. Next, the second point. The second point says that the oxidation number of simpler ions is equals to the charge on the ions. What does it say? So suppose we are taking a compound which is made up of ions. So in that case, the oxidation number will be the charge on that ion respectively. Suppose we are taking an example of NaCl, right? We are taking an example of NaCl. So here NaCl is composed of ion which is Na plus and Cl minus. So the oxidation number of sodium will be +1 and the oxidation number of chlorine will be -1. Is it clear? So I am saying that we have NaCl, right? It is an ionic compound which is composed of two ions which are Na plus and Cl minus. So what will be the oxidation number of sodium here? So I'm using a shorthand, that is oxidation number On. Okay, so oxidation number of sodium will be +1. Similarly, which is equals to the charge, which is equals to charge on sodium atom. Similarly, oxidation number of chlorine is equals to -1, which is again the charge on chlorine atom. So this is our second point. So we can take more examples like this. Suppose we have CaCl2. It is again an ionic compound in which Ca will have 2+ charge and Cl will have -1 charge. So you know this compound very well. You must not get confused what will be the composing ions of this, right? So there will be 2 Cl minus. So since I'm not balancing stoichiometry here, so it is composed of two types of ion which are basically Ca2 plus and Cl minus. So that would be more appropriate to write. Yeah. So if I say that what is the oxidation number of calcium here, so you will simply say, sir, it will be +2. Why +2? Because the charge on calcium is +2, right? Again, if you are asked that what is the oxidation number of chlorine, then you will say, sir, it will be -1. Is it clear? Right. So this is the thing that you should consider as the second point. Then what is the third point? The third point says that the oxidation number of hydrogen is 1, +1. When it is +1, when it is combined with a non-metal. So two cases are there. So first case is that hydrogen. So first thing is that hydrogen can have only two oxidation number. That will be either +1 or -1, right? Because if it is getting one electron, it is completing its octet, and that's it. It will not acquire any more electron. Similarly, it has only one electron, so it can lose at last one electron. It cannot lose more than one electron. So two cases arise, +1 and -1. So if I talk about +1, so if it is combined with a non-metal, then it will always have a charge of +1. So we have the example. We have kind of 4 examples are given here. So it is CH4, NH3, H2O, HCl. So in all these cases, if I say we have CH4, right? We have, say, NH3. Sorry, we have NH3, we have H2O, we have HCl. If you want more examples, we can have, say, HF. We can have HF. We can have, say, this H2S. So in all these compounds, in all this compound, the oxidation number of hydrogen is +1. What is the oxidation number? The oxidation number of hydrogen is +1. This is the case of +1. So if it is combined with a non-metal, then it will have an oxidation number of +1. Again, when it will have -1, so if it is combined with a non-metal, if it is combined with a metal, then in that case it will have a charge of -1. So this is the thing. So if it is combined with non-metal, it will have a charge of +1. If it is combined with metal, it will have a charge of -1. So what are the examples? So for a common example is sodium hydride. So it is you can say hydride donor, NaH. It is a kind of base also. So more examples are possible. We have LiH, we have CH2, we have LiLH4. So in all these cases, the oxidation number of hydrogen will be -1. So this point should be clear. Okay. So let us move to the next rule. The next rule says that the metal in group 1A form compounds in which the metal atom has an oxidation number of +1. So what is this 1A? So basically it is group 1 according to the new periodic table. So in which we have alkali metal, which are our lithium, sodium, cesium, and say potassium. So all these metals will have oxidation number of +1 if they are forming compounds with a non-metal. With a non-metal, you can say. So here are our examples. So if it is Li3N, so it will have a charge of +1. So 3 lithium will have a charge of +1. It will be +3. Again, here we have another example in which sodium will have a charge of +1. Similarly, we can have CsCl2, which is cesium chloride. In this case also, the cesium will have a charge of, CsCl will have a charge of +1. So all group 1 element specifically, this is our old notation. We in modern times, we do not use this 1A, 1B and all. So we simply say it group 1. So all the group 1 metals will have an oxidation number of +1. Similarly, all the group 2 elements, if it is forming compound, they will have a oxidation number of +2. So the alkali metal will have oxidation number of +1 and the alkaline earth metals will have oxidation number of +2. So we have examples. The first one is Mg3N2, which is magnesium nitride, calcium carbonate. So in both these cases, magnesium will have a charge of +2 and again calcium will have a charge of +2. You can have more examples. we can have say MgCl2, in which Mg will have a charge of or oxidation number of +2. We have more examples, CaCl2. Here also Ca will have a charge of +2. So this is our next of the two rules. Now some of the elements have a fixed oxidation number. There are exceptions, right? There are always exceptions to our chemistry, but there are some elements or say atoms which will always have a general oxidation number. So if you are saying about oxygen, then I will say that it will have an oxidation number of -2 always. There are only 3 exceptions, 3 to 4 exceptions to it, out of which 2 I have already discussed. So if I have O2 or O3, then it will have an oxidation number of 0. You know it well. It is an homoatomic neutral molecule, so it will have a charge of 0 or oxidation number 0. See this example. So why it should be neutral? This can be cleared here. So in this case, you will not say that the oxygen will have a charge of 0. Why? Because the overall charge on this compound is -2, so it is not say neutral, and therefore the oxygen will have a charge of -1 to make this charge validate. Okay, so if each atom of oxygen will have a charge of say -1, then 2 oxygen will have a charge of -2. Therefore, the overall charge can be validated. So this is a good example of why I was telling that it should have 0 charge on that compound for the homoatomic molecule to have each of its atom as oxidation number 0. Next, we have another example. We have H2O2. So in this case also, oxygen will have a charge of +1. So -1. So 2 oxygens will have a charge of -1. It will be overall charge due to oxygen atom will be -2. Similarly, hydrogen will have a charge of +1. See here, hydrogen is having a fixed +1 charge. Okay, it cannot be varied. It cannot donate more than 1 electron at it is the maximum number of electrons it contains, and that is 1. So it can have maximum positive charge of +1 and not greater than this. Due to this reason, in this compound, we are having a charge on oxygen atom, an oxidation number of oxygen atom as -1. So here, true hydrogen atoms will have a charge of +1, which will be equals to which will be add up to +2. Similarly, the oxygen will have a charge of -1, and the 2 oxygen will add up and give it as -2. Right? So this is our thing. So these are our exceptions. So if I tell in general, so if there is a polyatomic molecule which contain oxygen-oxygen bond, then the case can arise that oxygen will have a charge not equals to -2. You can remember all this and you can deal with rest of those with -2. So these are the 4 exceptions. Next, the element of group 7A. You can say 17 more specifically, because now it is named as 17. So elements of group 17 will have a charge of, or say oxidation number of -1 when it is combined with a metal. Then and then only it will have perfectly a charge of -1. If it is not combined with metal, there is a chance that this charge can vary. So example is, so if you are taking OCl2, in which oxygen is a non-metal, then in this case oxygen will have a charge of -2, but chlorine will have a charge of +1. So 2 +1s will add up to +2, and overall it will have a neutral molecule. Alright, so this is our thing. So I was talking about that group 17, if they are forming compounds with a metal, then the charge on this element will be -1. So here is the case. So aluminum has a charge of +3, and each fluorine atom has a charge of -1. So adding all those 3, -1, -1, -1, we will get -3. So -3 plus 3, the overall charge on this compound is 0. Similarly, we have HCl. So it is an exception, you can say. Sorry, exception not, means you can say generalization, but you cannot generalize it always, because Cl can have a charge of positive. also plus 2. It can also have a charge of plus 2 also in some cases. So let us for now say that it always combined with metal and has a oxidation number of -1. In case of non-metal, it may vary. Like here is the example HCl. It will have a charge of -1. But how? So since I've told you earlier that hydrogen can never have a charge of greater than +1, and it will have -1 only and only if it is combined with a metal. So since chlorine is a non-metal, so it will have a charge of +1, and hence chlorine will have a charge of -1, so that overall charge can be 0. Our next example is ZnBr2. Here also the bromine will have a charge of -1. So 2 bromine means -2, and Zn will have +2. So overall it will be 0. So these are all rules that you should remember. So if I get a glimpse of all of those. So first was that if we are having a homoatomic neutral molecule, then a charge on each of the atom will be equals to 0. That was the first rule. The second rule was that if the compound is ionic, if it is composed of ions, then the oxidation number on each of this atom will be equals to the charge. This was our second rule. What was our third rule? The third rule says that what was the third rule? I forgot. The third rule says that if the hydrogen is present, then in that case, if it is combined with metal, then it will have a charge of -1. And if it is combined with non-metal, it will have a charge of +1. Now the metal of group 1A will have a charge of +1 if it is combined with non-metal. And if it is group 2 element, then it will have a charge of +2 if it is combined with non-metal. Then oxygen usually have a charge of -2, but there are exceptions. The 4 exceptions are ozone, oxygen, H2O2, O2 means basically if there is a oxygen bond, then in that case it will have a charge of -2. Then group 17 elements such as fluorine, chlorine, bromine, iodine, if they're forming a compound with metals, then it will have a charge of -1. If it forming compound with say non-metal, then it can vary. So these are our 8 rules. Now we have some examples here. So the first example is of H2O. A simple example which says that here hydrogen has a charge of +1 as it is combined with a say non-metal. So there 2 oxygen will have +2. Sorry, 2 hydrogen will have +2 and 1 oxygen will have -2. So overall charge will be 0. Next we have SO4 2- in which oxygen will have a charge of -2. So 4 oxygen will have a charge of -8 overall, and sulfur will have a charge of +6. So the overall charge will be -2. Here the charge is -2, so we have equilibrated to its overall charge. Then we have the example of SO2. So since oxygen will have a charge of -2, so 2 into -2 will be equals to 0. Sorry, -4. And sulfur will have a charge of +4. Therefore, overall charge will be 0. So, one more thing I want to mention here is that if someone's oxidation number is unknown and you know the suppose there are 3 elements, right, in a compound, and you know the oxidation number of 2 exactly, then what you should do, then you should assume the third element of whose oxidation number you are unaware about or you are confused, and put it as X. Then add overall charge and make it equal to the charge on the whole compound. If it is neutral compound, take it as 0. If it is positive or +1 +2, make it as +1 +2 equals. If it is negative -1 -2 or -3, make it equal to -1 -2 -3. Then solve for X and get your oxidation number. Likewise, if here suppose you do have no knowledge about the oxidation number of sulfur, then you can put X here. So this will give you X plus 4 minus 2, and overall charge on this compound is 2 minus. Just solve for X, you will get your plus 6 back. Yes. So in this way you can calculate the oxidation number of your unknown atom. If you are confused about it, you can use this simple trick, or you can say formula, anything you want, and find the oxidation number. Now remember all these points, 8 points. We will be using back and forth all of this 8 points in the coming slides. So what is redox reaction? So what is redox reaction? So if I tell it simply in terms of reduction and oxidation. So if in a reaction, both reduction and oxidation are taking place simultaneously, then we say that we are having a redox reaction. Now, what is this oxidation and reduction? Now, you must have seen these terms earlier also, and you have seen their definitions also, right? So you must have seen these definitions like if an compound is losing oxygen, okay, if it is losing oxygen or gaining hydrogen, in both these cases you said that it is reduction. So this was our rule for reduction. And if we are talking about oxidation, then we say that yes, if it is gaining oxygen or if it is losing hydrogen, then in that case we say that okay, it is having oxidation. So that was our previous point of view, and you can say it is kind of primitive. Likewise, because it cannot be applied further, oxidation reduction is beyond that formulation. So what is the new formulation you should remember? And it would be applied to each of your next compound or next example. Whenever you want to see that something is getting oxidized or reduced, you can generalize it using this new definition. So what is that definition? So if you ask about oxidation, you can say it simply that what is oxidation? It is loss of electrons. So if something is losing electron, then it is oxidizing. And if something is gaining electron, then it is getting reduced or it is getting reduction, right? So these are our new general formalization. So how you will find out that if something is gaining or losing electron? Simple, just assign the oxidation number to it. And then see that if the oxidation number is increasing more towards positive, then you will say that okay, if it is getting oxidized and is it losing electron and gaining more positive charge. If its positive charge is reduced or if it is moving towards negative charge, then you will say that okay, since in this case it is having a greater negative charge, so it is getting reduced. Why? Because it is getting electrons. So a simple example here it is given. So since sodium is an elemental form and no other atom is present and overall charge is neutral, so it will have a charge of oxidation number of +1. 0. Similarly, chlorine is a homoatomic molecule and of course a neutral molecule. So the oxidation number of chlorine in both the chlorine will be 0. Right. Next, if we see this compound which is formed by the combination of these two, so sodium will have a charge of oxidation number of +1. Why? Because it is an ion which is having a charge of +1. So if its oxidation number will be also +1, similarly, chlorine will have -1. Now, if you see here, you can see that sodium was having initially a charge of 0, then it moved to +1, means it is moving towards positive side and it is losing electrons. So one sodium atom is losing 1 electron here. Similarly, chlorine is gaining electron. How? Because it was initially having a charge of 0. Now it is having a charge of -1. See, you can see the difference. Now since we are considering 2 moles, so 2 moles of sodium will lose 2 electrons. So 2 molecules of sodium will lose 2 electrons, or 2 atoms of sodium will lose 2 electrons and become Na+. Similarly, one chlorine molecule or 2 chlorine atom will lose 2 electrons, gain 2 electrons and will have a charge of -1. So this is our example. So we can have other examples also. So here also sodium is losing 2 electrons and becoming Na+. So each sodium is losing 1 electron. So 2 sodium will lose 2 electrons. Right. Here also oxygen is having 0 charge oxidation number on it. So both of the oxygen will have an oxidation number of 0. Now it will gain 2 electron and become 2-. Similarly, this is having the similar analogy. So this is called redox reaction. Why? So in each of this, we are seeing a loss of electron, that is oxidation, and we are seeing a gain of electron, which is reduction. So they both are occurring in a same reaction. So you can say they both are occurring simultaneously. One is losing, one is gaining. Therefore, it is an example of redox reaction. So in a reaction in which both oxidation and reduction take place simultaneously, then you will say that, okay, it is example of redox reaction. Next one is electrochemical cell. So what is electrochemical cell? So electrochemical cell, we have seen that what is redox reaction. So if we split the redox reaction into two halves, right? If we can split the redox reaction into two halves, in the previous examples, you cannot split it, right? Because they both were combining and giving the same compound. But if there is a reaction in which the reduction and oxidation can be splitted into two half reactions, then they can be put upon in a setup called electrochemical cell. We will see more about this later on. So for now, just remember this point, that if we can put the half oxidation and half reduction reaction in two compartments, we can symbolize them in two compartments, then you will say that it is an electrochemical cell. Okay. Next thing, I will get to the diagram in the next slide. The type of galvanic electrochemical cells are two. So based on something new that we will see in later lectures, it is of two types, galvanic and electrolytic. We will see these two variations later on in more detailed manner. So here is the diagram of electrochemical cell. So now I will explain each and every component of this electrochemical cell. So these are electrochemical cells. Here it is the first one. So here what is happening? So I will not get into the complications right now. I will just give you an overview of this. We will see this in the next lecture, what is happening in the solution and what is happening outside the solution in the wires. So in the first one, we are having a case where it is saying that the potential which we are applying. So this is a circuit. Okay, just keep it in mind whatever I'm saying. Do not get into the reactions that is going on. Just take it as a symbol of circuit. This is a circuit. Okay, this is a complete circuit. Now what we are doing, we are applying voltage here with the help of a cell. So if that voltage is less than 1.1 volt. Okay, if it is less than 1.1 volt. So 1.1 volt is something that is the potential of this circuit. So if we are applying current in the opposite direction and such that the current is less than the potential that is going on, means the potential that is being in this circuit. So this is one circuit here, and the second circuit we are applying opposite potential to it. So if the opposite potential is less, then the reaction that is going on here will be due to the chemical reactions in the solution, and in that case we will term it as galvanic cell. So is this clear? So just keep these things in mind. For now, I'm not going into the reactions. So in galvanic cell, what is happening is that we are applying, we are having a reaction. We are having, current that is due to the reactions. So if we are having energy, that is electrical energy due to chemical reactions, then it is galvanic cell. Next is, if the energy released due to the reaction in these compartments and the external potential are both equal, then no net current will be seen. So the deflection will be zero and there will be no flow of electron. So no chemical reaction. And the third case is that we are having an external potential which is greater than 1.1 electron volt that was due to the solution reactions. So in that case, we will term it as electrolytic cell. So it is galvanic cell. So in this, we are having a chemical reaction and the electrical energy is produced. In this, we are having electrical energy and this electrical energy drives our chemical reaction. In this case, we say it as electrolytic electrolytic cell. Okay. So these are our three cases. And the third case is in which both the opposing potential are same. So no net current is seen. So what is the difference between these two? So in electrolytic cell, what is happening? We are using the Gibbs free energy of spontaneous. Sorry for this. This will be galvanic. And this will be electrolytic. So in galvanic cell, what will happen? The Gibbs free energy of the spontaneous redox reaction means if this reaction is having spontaneous, and the Gibbs free energy of this reaction is converted into electrical energy. And in the opposite reaction, what is happening? The electrolytic cell, what is happening? We are using the electrical energy to drive the non-spontaneous redox reaction. So if a reaction is spontaneous in one direction, it must be non-spontaneous in the other direction. So what we are doing, we are using this principle, and when we are applying a voltage that is less than your Gibbs free energy, or you can say the potential of the spontaneous redox reaction, then we are getting galvanic cell. And if it is greater than the potential of the circuit, then we are having a electrolytic cell. So these are the two divisions. So you should remember this. But this is not the actual case that we are applying voltage and seeing it. In galvanic cell, we are having no voltage, means we know our goal. So we do not apply voltage in the galvanic cell. And if it is electrolytic cell, we don't know our goal, so we apply voltage to it. So the reaction that is going in the galvanic cell, there are two reactions. So I have said you earlier that a redox reaction can be split into. That can only be converted into electrochemical cell. So the two reactions are oxidation half reaction and reduction half reaction. Why it is oxidation half? Because Y is going into Y plus by gaining one electron, and Z plus is going to Z by gaining an electron. So overall reaction will be Z plus Y plus Z, that is giving Y plus and Z minus, and its Gibbs free energy is less than 0. Yes, then only the reaction will be spontaneous, in the case in which the Gibbs free energy change is less than 0 or negative, then in that case only we are having a spontaneous redox reaction. And the spontaneous redox reaction, the Gibbs free energy of spontaneous redox reaction is converted into electrical energy. When we are talking about electrolytic cell, so similarly we will do the opposite thing, just the opposite thing. We will the Z minus will give Z and electron, and the Y plus will combine with an electron and give Y. Okay, so the opposite reaction will happen, and the overall reaction will be Y plus and Z minus are giving Y and Z. And in this case, in this direction, the reaction is non-spontaneous because Gibbs free energy is greater than 0 or positive. In this case, what we are doing, we are converting the electrical energy into Gibbs free energy that can drive our non-spontaneous redox reaction. Next are the terminologies. So here is electrochemical cell. Okay, here is an electrochemical cell. So we have components of this electrochemical cell. The first one is cathode. So this is our cathode. It is positively charged. Just remember the terminologies right for now. What is happening in the reaction till now I have not introduced. I will introduce in the next class. Okay. So we have our cathode, which is positively charged. We have our anode, which is negatively charged. Right. And we have our cation. So here we have cation and we have anion, and we have anion negatively charged. So cathode is negatively charged electrode, anode is positively charged electrode, cation is positively charged ion, and anion is negatively charged ion. So remember this thing. So they both are just opposite of each other. So if cation is positively charged, the cathode is negatively charged. The anion is negatively charged, then anode is positively charged. So these things may confuse you in a way. So how do we get rid of this terminology? So this is a mnemonic device you can use. It is called LONE. So it will help you to remember this. So what does this LONE mean? So if you see here, you can see that on the left side oxidation is happening. Okay, on the left side oxidation is happening, and this is a this is a nomenclature. You can say this is the convention that will follow. That oxidation will always happen on the left side. Okay, so remember this thing that and how will remember this? Using this LONE. So what does this LONE represent? The L represent that we are having the reaction on left, which is oxidation, and anode is present on the left side, and anode is negatively charged. So in a nutshell, L represent left, which on the left side we are having oxidation, and we are having anode which is negative charge. So the opposite of this is also true. So if we are moving to right, then oxidation will turn to reduction, anode will turn to cathode, negative will turn to positive. So at right side we will have reduction, and there will be cathode which will be positively charged. Okay, so this is our thing. So this is not positively charged. Sorry, this is not positively charged. These are having negative ion on left side. Okay, so if you see here, okay, so anode is negatively charged. Anode is negatively charged. Yeah, right. Anode is negatively charged. So this is our LONE. So with this, I want to end my lecture. So I hope you have understand what is cathode, anode and all those, and what is oxidation number and redox reaction. So in this class, I was mainly focusing on oxidation number and redox reaction. So in the next class, we will see how does this galvanic cell works. What is the reaction that goes throughout this galvanic cell. Then we will move to our next concept, that is EMF, and later on. So thank you for today's time.